The next one is rationalization. 1/6. Rationalization. In general, one over root A is identical to 1 over root A multiplied to root A over root A. The left-hand side is equal to the right-hand side. By any means, if this one and this one cancels out, then you can see that the left-hand side is equal to the right-hand side. This is what is called, this is what referred to as rationalization. So if you expand it further, you can see that we have their numerators multiplied together as the denominators also multiply together. So 1 times root A is equal to root A. Root A multiplied to root A, which is not different from root A over A, meaning root A times root A is equals to A, which indicates that root 5 times root 5 is equals to 5. Let's say root 2 times root 2 is equals to 2, which means root A multiplied to root A is equals to A. So as root A here multiplied to root A here, we have A. Therefore, 1 over root A is equals to root A over A. Let's see. Let me call this section 1. For instance, if you have 1 over root 3, then following the same example or the same strategy, you can see that 1 over root 3 is equals to 1 over root 3 anyway, multiplied to root 3 over root 3, which is equals to 1 multiplied to root 3 over root 3 multiplied to root 3, which is equals to root 3 over 3, because root 3 times root 3 is equals to 3. We said root A multiplied to root A is equals to A. Therefore, 1 over root 3 is equals to 1 over root 3 is equals to root 3 over 3. Take your time, copy it. I'll call this one part 2, the second part of the board, while this one is the first part of the board. Okay, take your time, copy it, and we stretch forward for more examples. Let's take another simple example on this side. Let me call it section 3 of the board. And the question says that rationalize (7 over root 3). 7 over root 3 solution. 7 over root 3 is identical to 7 7 over root 3 multiply to root 3 over root 3. We have 7 root 3 over root 3 times root 3, which is equals to 7 root 3 over 3. Therefore, 7 over root 3 is equals to this. Okay. We are continuing the analysis. At this time, the question says that express in its simplest form which is root 450. Solution. Root 450 is no different from 50 times 9. 50 times 9. This can also be expressed as root 50 multiplied to root 9. But root 50 can also be expressed as 25 times 2, then multiply to root 9. Then this one can also be expressed as root 25 multiply to root 2 multiply to root 9. Root 25 is equals to 5 times root 2, which is being multiplied to root 9. Root 9 is 3. So it becomes 5 multiplied to 3 root 2, which is also equals to 15 root 2. Therefore, root 450 is equals to 15 root 2. Take your time, copy it, and we'll move forward. The next question is similar to the previous one that we considered. This one, at this time, it is 125. Solution. Root 125 is no different from 25 multiplied to 5. And then you have root of 25 being multiplied to root 5. This one is a rational number, and this one, it will end up with insert. Root 25 is equals to 5 multiplied to root 5. We leave it in this form. Therefore, 125 root 125 is equals to 5 root 5. Good. We take the next question. In the same way, root of 75, root of 75 is equals to 25 times 3, which is equals to root of 25 multiplied to root 3. Root 25 is equals to 5. However, root 3, we leave it in that form. Therefore, root 75 is equals to 5 root 3. Take your time to copy. We'll take the next question. The next question says that simplify (1 over 1 plus root 3). Solution. If you have an expression like this and you are requested to simplify, this is how it goes. In rationalization, you write down what is given: 1 over 1 plus root 3 multiply to, at this time, it should be 1 minus root 3 over 1 minus root 3. You change the sign here in rationalization. So this one becomes 1 multiplied to the numerators is equals to 1 minus root 3. And the denominators is 1 plus root 3 multiplied to 1 minus root 3, which is equals to the numerator 1 minus root 3 over the denominator 1 times 1 is 1. 1 times minus root 3 is equals to minus root 3. Then you come here, root 3 times 1 is equals to root 3. Then you have plus root 3 minus root 3. Remember, we said that root a multiplied to root a is equals to a. So you can see that if we multiply root 3 plus root 3 minus times minus root 3, it becomes root 3 becomes 3. So we have here the numerator 1 minus root 3. This one is plus. 1 multiplied to 1 is that. 1 multiplied to minus root 3 is that. Plus root 3 multiplied to 1 is plus root 3. Minus root 3 multiplied, plus root 3 multiplied to minus root 3 is that. So this one will cancel this one. So we are left up with 1 minus, because of this sign. Root 3 times root 3 is equals to 3. Therefore, this is equals to 1 minus root 3 over minus 2. Or you can make it this way. You can make it like root 3 minus 1 over 2, meaning you multiply both the numerator and the denominator by negative 1, or negating both the numerator and the denominator. Yeah. Take your time to copy it while we move further. The next one, it says simplify. One over 2 plus 3 root 6. This expression is no different from 1 over 2 plus 3 root 6 multiply 2 2 minus, we change the sign, 3 root 6 over 2 minus 3 root 6. We change the sign. So it becomes 1 multiplied 2. This one, it remains the same. 2 minus 3 root 6. All over the denominator, 2 plus 3 root 6, which is this one, multiply to 2 minus 3 root 6, which is equals to the numerator 2 minus 3 root 6 all over 2 times 2 is 4. 2 times minus 3 root 6 is equals to minus 6 root 6. 2 times 3 root 6 is equals to plus 6 root 6. Then 3 root 6 multiplied to minus 3 root 6 is equals to minus 3 times 3 root 6 times root 6, which is no different from this one cancels this one. So you are left up with 2 minus 3 the numerator 2 minus 3 root 6 over 4 minus 3 times 3 is 9. Root 6 times root 6 is 6. So if we continue on this side, it becomes 2 minus 3 root 6 over 4 minus 36. Sorry, minus 54. 9 times 6. Yeah, it's 54. 4 minus 54. Let's check it. Yeah, it's correct. It's equals to 2 minus 3 root 6 over minus 50. Or you can leave it in this form, or you can negate both the numerator and denominator. So it becomes 3 root 6 minus 2 over 50. Whichever way. Take your time, copy it, and we'll take another example. This is video, so you can pause it and then go through it and then copy everything. we are going to take another example. It says that rationalize the denominator and simplify. Rationalize. One over root 2 plus 1 plus 1 over root 2 minus 1. Good. I think we'll use the same strategy that we used in the previous analysis. This one, it becomes solution. We are considering this one first. So 1 over root 2 plus 1 times root 2 minus 1, we change the sign, over root 2 minus 1. Then we have here this one plus this one, 1 over root 2 minus 1 then we rationalize it. At this time, we also change the sign. It is negative here. It is going to be positive here. And we do the same thing for the denominator. Good. This is no different from 1 multiplied to 2 minus 1, root 2 minus 1, which is root 2 minus 1 is the numerator. And the denominator, we have this one as this, and let's correct this one as well. Make it nicer, neat. Root 2 multiplied to root 2 is equals to, remember, we said that root a multiplied to root a is equals to a. So root 2 multiplied to root 2 is equals to 2. Root 2 multiplies to minus 1 is equals to minus root 2. Root 2 multiplies to 1 is equals to plus root 2. 1 multiplied to minus 1 is equals to minus 1. This one will cancel this one. Then the bracket, don't forget, is here. And the plus sign is there. And we are dealing with another one. This one, 1 multiplied to the whole thing is equals to root 2 plus 1 as the numerator. And root 2 multiplied to root 2 is equals to 2, as we've already explained. Root 2 multiplied to 1 is equals to root 2. Here, root 2 multiplied to negative 1 is equals to negative root 2. Minus 1 multiplied to 1 is equals to 1. This one cancels this one. So we are left up with the numerator is root 2 minus 1 over 2 minus 1. Good. Which is this one. Then we have here in the bracket we have root 2 plus 1 over 2 minus 1. So we have here root 2 minus 1 over 1 plus root 2 plus 1 over 1. Then if we continue, then we will have is equals to root 2 minus 1. Root 2 minus 1 over 1, root 2 minus 1 all over 1 is the same. So the bracket becomes this way, and this one plus, see the plus there, root 2 plus 1. So we clean it up. We have here root 2 minus 1 plus root 2 plus 1 is equals to root 2 plus root 2 plus 1, which is this one, minus 1. This one and this one cancels out, so you have 2 root 2. Therefore, 1 over root 2 plus 1, which is this one, plus 1 over root 2 minus 1 is equals to 2 root 2. That should be the final answer. Take your time to copy everything. And by the way, as this is a video tutorial, you can pause it as I've stood aside just to make the board clear to you to copy. You can pause it and then go through everything and then copy everything down. On that same question, there is another strategy that we can use to come by the same results, which I want to demonstrate. If you have something like this, then you just cross multiply. So it becomes, this one goes there to multiply to that one, so it becomes 1 times root 2, as this one is going there, minus 1, then the plus over there, and this one comes here to multiply to the 1, so it becomes 1 times root 2 plus 1. All have a common denominator, which is this one and this one being multiplied together. So we have root 2 plus 1. And we have root 2 minus 1. So this one becomes 1 multiplied to the whole root 2 minus 1. It becomes root 2 minus 1. Then you have plus. 1 multiplied to root 2 plus 1 then becomes root 2 plus 1. It stays the same. With a common denominator, root 2 multiplied to root 2 is equals to 2. As we've already said, that root a multiplied to root a is equals to a. We have said that already. So in that case, root 2 multiplied to root 2 is equals to 2. Then root 2 multiplied to 1 is equals to minus root 2. Then 1 multiplied to root 2 is equals to plus root 2. Then 1 multiplied to minus 1 is equals to minus 1. Then we go further. You can see that we have up there, we have 2 root 2 plus root 2 minus 1 plus 1. This one cancels this one, so we are left up with 2 minus 1. Then if we extend, so it becomes, this one cancels this one, so we are left up with 2 root 2 at the numerator. And 2 minus 1 is equals to 1. Is equals to 2 root 2. Exactly the same as we had in the previous approach. I'm standing away from your way for you to go through everything that we've done. And take your time. Cogitate on everything. And then take your time to copy. You can pause it as a video while I'm standing away from your way. We take another example. For instance, if you are given an expression like this, and you are requested to rationalize 1 over 4 minus root 10. This is no different from 1 over 4 minus root 10 being multiplied to 4. It will be plus at this time because we are rationalizing it. 4 plus root 10 all over 4 plus root 10, which is no different from 1 times 4 plus root 10 over the denominator 4 minus root 10 be multiplied to 4 plus root 10, which is no different from 1 multiplied to the whole thing. It says the same, so we have the numerator to be 4 plus root 10 all over 4 multiplied to 4 is 16. Then we have 4 multiplied to root 10, we have 4 root 10. Then we come back, minus 10 multiplied to 4, we have 4 minus root 10. Then we have minus 10 being multiplied to root 10, we have minus root 10 times root 10. Then it becomes 4 plus root 10 all over. Remember, this one cancels this one. So you are left up with 16 minus root 10 being multiplied to root 10 is equal to 10. So you are left up with 4 plus root 10 all over 16 minus 10 is equals to 6. So this should be the final answer. Good. Take your time to go through and copy everything down. Remember, this is video. You can pause it while you are going through, and then later on you can copy it down. The next question is rationalize 1 over root 5 minus root 3. The one is here. This is no different from solution. This is no different from 1 over root 5 minus root 3 being multiplied to root 5. It is negative here, it will be positive, root 3, divided by root 5 plus root 3, which is not different from 1 being multiplied to root 5 plus root 3 all over root 5 multiplied to root 5 is equals to 5. Root 5 multiplied to root 3 is equals to 5 root 5 times root 3. Then you come here. Root 5 or minus root 3 multiplied to root 5 is equals to minus root 5 being multiplied to root 3. Then you have minus root 3 being multiplied to plus root 3. So it becomes minus 3, or let me not rush. It becomes minus root 3 being multiplied to root 3. So 1 multiply to this expression, the expression remains the same. So the numerator is 5 root 5 plus root 3. And the denominator plus root 5 multiplied to root 3 minus root 5 multiplies to root 3. This one and this one cancels out. So we are left with 5 minus root 3 times root 3 is equals to 3. So we are left up with root 5 plus root 3 over 2. Therefore, 1 over root 5 minus root 3 is equals to this. Take your time, copy it. Yeah. Good. Good. The next question. The next question, it says that express the following as a square root. The first one is A 4 root 5. B 3 root 2. C root 2 over 2. D 2 over root 6. Solution. A, you have 4 root 5. And we are requested to express this expression as a square root. How do we do that? To do that, the 4 here, I'll push it inside. I'll push it inside the square root. It becomes the square root. As the 4 has been pushed inside, I square it. And then multiply to 5. If you push the 4, which is outside, into the square root, you have to square it. So it becomes 16 times 5. This, which is no different from root 80. We are dead with it. Then let us come to this one. Root 3, root 2. I'll push the 3 inside the square root. To do that, I will square the 3. So it becomes 3 being pushed inside. I square it times 2. Then I put the square root, cover it with the square root. So it becomes 3 raised to the power 2 is 9 times 2, the square root. So it becomes root 18. Then I come to this one. This one. To push this one inside the square root, I should still have to square it. So root 2 over 2 is no different from pushing that one inside the square root. It becomes 2 over 2. That is being pushed inside the square root. Come 2 squared. In that case, it becomes 2 over 4. It becomes 1 over 2. It becomes 1 over root 2. You leave it that way or that way. Then another one, which is the D. the d is also the same. 2 over root 6. I'm trying to cover the 2 also with square root, so it becomes 2 being forced inside the square root becomes 2 square over 6. It is forced inside the square root. Therefore, 2 raised to the power 2 is 4 over 6 in square root, which is no different from, you can leave it like this, or you can. 2 goes here, 2 goes here, 3. So we can 2 over 3 in the square root. Therefore, 2 over root 6 is no different from that. Take your time to copy it. Yeah. So this one was also one of the things that you are expected to know in basic algebra, like this. Okay, take your time, copy it as we take the next question. The next question, it says that simplify root 3 plus 2 plus 1 over root 3 minus 2. Good. This is no different from root 3 plus 2 plus, then I'll rationalize this one. 1 over root 3 minus 2 root 3 plus 2 root 3 plus 2 is equals to root 3 plus 2. Then there's a plus here. Then this one becomes 1 multiplied to root 3 plus 2 over root 3 minus 2 multiplied to root 3 plus 2, which is no different from root 3 plus 2 plus the numerator, which is root 3 plus 2 over, then root 3 minus 3, root 3 multiplied to root 3 is equals to 3. Root 3 multiplied to 2 is equals to 2 root 3. Root 3 multiplied to minus 2 is equals to minus 2 root 3. Minus 2 multiplied to 2 is equals to minus 4. Which is root 3 plus 2 plus root 3 plus 2 over this one cancels this one, and this one becomes root 3 multiplies to root 3 is equals to 3. then minus 4. So if we continue, then we can say that is equals to root 3 plus 2, which is this one, plus root 3 plus 2 over 3 minus 4 is equals to minus 1. So it becomes root 3 plus 2 minus root 3 plus 1. Because of this minus. So it becomes root 3 plus 2 minus root 3 minus 1. Sorry. This is 2. This is 2. So it becomes minus root 3, which is this, minus 2, which is this. So comparatively, you can see that root 3 cancels root 3, minus root 3. 2 cancels with minus 2. So you are left up with 0. Therefore, the given expression, root 3 plus 2 plus 1 over root 3 minus 2 is equals to 0. That should be the final answer. So, cogitate on the whole thing and take your time to copy as we bring this rationalization to conclusion. The next thing that we will do is we are going to solve past questions from different examples. For instance, from the Edexcel, AQA, and OCR. Yeah. Take your time. Copy everything.